Okay, so Thevenin's theorem states that an entire network consisting of active and passive sources. So active sources are the voltage or current sources, while passive sources are resistances, capacitors, inductances. So in case of DC, we will restrict our discussion into DC, so we will just consider resistances, but it's also applicable for uh, AC cases. But anyway, so it states that the entire network at any point can be replaced by one voltage source and a resistance, and the voltage source is called Thevenin's voltage and the resistance is Thevenin's resistance. So basically at any point the entire network, let's say at this point we want to replace this whole network. So Thevenin's theorem says that this entire thing can be replaced by one voltage source and one resistance. So if this point is A, this point is B, this is A and B. So it is possible. That's what Thevenin's theorem say. Now how it's useful is if we want to, if our interest is just to find the current through R7, then instead of solving current or voltages in all the elements, we can just use Thevenin's theorem. So we can replace the whole network by one voltage source and resistance. So we can find the Thevenin's equivalent here, and then we add this R7. We can easily solve it. Now the question is how to find Thevenin's voltage and Thevenin's resistance. So to find the Thevenin's voltage, what is done is the circuit is open at this place, so it's made open at this port. So basically what's done, it is taken out here, and the open circuit voltage here is calculated. So basically what is the open circuit voltage VAB, that is calculated here, and that is called the Thevenin's voltage at this point. So everything else in the rest of the circuit to the left remains the same, left because we are talking about this portion of the circuit, so that stays the same, and we calculate the open circuit voltage here, that is the Thevenin's voltage. And how the Thevenin's resistance is calculated? Okay, in order to do that, what is done is all the active sources in the network, in this part of the network, are made inactive. So they are made dead or inactive. That means the voltage sources are made short circuit, and if there is any current source like this one, that will be made open circuit. So basically the circuit will become something like this. This voltage source will be short circuited, the resistance stays like that, this voltage source again will be short circuited, E2, this resistance stays like that, R3, this is R2, this is R1, and this is short circuited, this is R4, and this current source is open, so here there is an open, and this is R5 stays there, and then this is R6 stays there. Now the equivalent resistance from here is calculated. This equivalent resistance is R Thevenin. That's what it is. So that's how it is calculated. So this is the theory. I will discuss an example maybe with the same circuit in another video, but this is the theory. So the entire network can be replaced by one voltage source, which is the Thevenin voltage, which is actually the open circuit voltage looking towards the left from that point, and the Thevenin's resistance, which is the equivalent resistance looking towards the left from that point and making all the sources inactive. So current sources open and voltage sources short.